So I think it's interesting to go back now and relearn organic chemistry so I can put together a video series on how to do organic chemistry for if I teach the course or former students want to look at it. And I say it's interesting because my background is actually electrochemistry and material science and inorganic chemistry. And inorganic chemists and organic chemists absolutely hate each other. They think they are both terrible people. And for good reason. The inorganic chemists think the organic chemists are stupid. And they think they're stupid because they work with Lewis theory, which the organic chemists know is wrong. And they always draw simple molecules where there's always a solution, it's easy to work out. But on the other hand, the organic chemists point out the inorganic chemists can only work with little molecules because their little theory is too complicated for the little brains to figure out. So there is an interesting war. So I did this video series for a series of reasons, but one of the reasons, less important reason, is I wanted to reteach myself organic chemistry, and I really wanted to understand it better because as an inorganic chemist, I can do lots of weird things with transition metals. But to be honest with you, the complexities of organic chemistry, and there are some out there, are something I want to relearn. So what I want to do is I want to give you a video that gives you the full disclosure on how an organic chemist teaches and how they think. Because when you take organic, you're taking the first specialty chemistry. This is the first chemistry where there is a way to think about it. Because general chemistry 1 and 2 are challenging in different ways. One's qualitative, one's quantitative. But they're really just foundations. That's it. You have anything you learn in general chemistry 1, 2 can be applied to any of these other fields in a broad sense. Organic chemistry is very much a way of looking at the world, and you don't really see the flavors and the philosophies of organic chemistry pop up in something like inorganic chemistry or physical chemistry or quantum chemistry. It is the first time you take a chemistry course that is truly a specialized way of thinking about the world. So when I go back through and I start looking through my old notes and I start looking through the textbooks, the 3 things that really pop out to me about organic chemistry, and they're the 3 that I'm going to emphasize in these videos and I think are going to help you understand this better. First of all, organic chemists really concern themselves with nomenclature. And the reason they concern themselves with nomenclature is that these are very complicated molecules. And they need to find a way to elegantly and uniquely identify the molecule and capture all the important components of its chemistry and its properties. So as we start working through videos and we start building up the complexities of nomenclatures, ask yourself what would be the easiest way or the most unique way to name this molecule. And this is typically where our rule is going to follow from. Now, the second, which kind of builds on this, is the geometry. They really worry about how the atoms are aligned in space, and there's good reason for this. If we change the geometry of the molecule, we'll change its physical and chemical properties. If we have a carbon-carbon double bond and we have 2 groups that are beside each other versus opposite each other around the double bond, this is going to really shift its properties based on how it interacts with light, how it interacts with itself, all types of things. Which brings us to the third part that organic chemists really love, and these are their mechanisms. They really want to know how to take a molecule and convert it to something else with certain properties. And they really care about the geometry when they finish. So in a lot of these videos, we're going to be talking about mechanisms, and we're going to be having a lot of overlap between videos because converting an alcohol to an aldehyde can be reversed to convert an aldehyde to an alcohol. The big thing to understand is, 1, how does it do it? And 2, how does it affect the geometry? How selective can we be? If we can end up with two different geometries, how do we dictate which one we finish up with? So this is the philosophy, in my opinion, of organic chemistry. Can you name it? Can you see it in space? And can you tell me how to convert it to different things and get the geometry and the types of materials you want to work with? So hopefully this video series is helpful for you, and start writing through them.